Hey guys, I've been trying to get closer to production mode with the Baliscissors. I've done lots of stuff, but not all of it makes for good videos. For example, I spent a lot of time designing and programming fixtures while I was waiting for more water jet blanks. When I did get the blanks, I measured them and found they weren't as accurate as I'd like. They ranged from 0.608 to 0.630. They were supposed to be 0.624. There's still extra material for me to make the handles, but this 22 thou variation in size means I might have to rethink my fixture. In previous videos, I also expressed frustration at the random sizing of blade stock. I decided to get some blades laser cut to see if it's any better than the water jet. They did arrive much quicker than water jet. It's CPM 154. They ranged in width from 930 wide to 934. That's much better, but the blanks are still too thick. They're around 113 thick, and I want about 0.94 or 3/32 of an inch. The thickness of the blades is important for the mechanism that switches between scissors and bally mode. Whenever I assemble the scissors for the first time, the buttons have been really stiff, which is a little strange because I've spent a lot of time getting a perfect fit with the pinholes. I've been facing the stock to the right thickness in the mill, but I haven't been getting great results. On this piece, the width is a few thou lower on one side, and the same goes for the length. That's awful. I worry that I can make perfect holes in pins, but if the blades are actually wedge-shaped, then when you stack them, the pin will get stuck. So, I finally got a surface grinder. After initially setting up the machine, I tried to balance a wheel the best I could. Then I dressed it. Then I tried balancing it again, and then I dressed it again, just to make sure everything's concentric. I'm not sure how much to take off when dressing. Most of the time when I redressed, I only took off a couple thou. Okay, now I can finally try grinding. I did a test on one of the blanks. The grinder has a magnetic chuck, so you don't need any fixtures for grinding steel. I wouldn't say I did an amazing job, but it got me brave enough to try grinding in the chuck. When I first got it, it had a 1 thou hill, and there was a weird line across it. I followed a long Tormox video. Unfortunately, this grinder doesn't have coolant, so they recommend using a thin layer of vegetable shortening to keep things cool. It seems to work as long as you don't put too much. The machine came with a 46 grit wheel. That sounds very gritty if you're thinking about sandpaper, but it's totally different with surface grinding. The chuck came out very smooth, and I definitely improved the flatness. Each of the ticks on this dial indicator is a 10,000th of an inch. I think I could probably get it even better, but I'll try it as is. I started removing the scale from the other side of the blank. I'm probably taking a 2 thou deep cut here, which is the deepest I've taken. I think the theory with surface grinding is, by using a magnet instead of a vise, and taking very small cuts with a grinding wheel instead of an end mill, you're putting much less stress in the material, which means you can create much flatter parts. The wheel does wear down over time, but you do most of the cutting with just the corner of the wheel, so most of the wheel will stay a true size and can make accurate parts. That's the theory, Unfortunately, I think things get more complicated with thin parts. I seem to have made a potato chip. I was afraid this would happen. With thin parts, if there's already any bend in the part, the magnet is strong enough to pull it flat. If you then take some material off, then demagnetize, the bend just springs back up. What's strange is these blanks weren't this bend to start though. Now I can fit a 16 thou feeler gauge underneath. That's almost as much material as I needed to remove to get to 0.094. But you can see I still have plenty of material and the thickness is fairly uniform. So I don't know if this is scrap. There are two reasons I can think of that I'd end up with more bend. One, maybe the part is heating up a lot. Apparently, if the part heats up too much, it'll expand into the grinding wheel. Two, by taking too much material off one side before the other, I'm relieving internal stress in the metal on one side more than the other. Maybe there's internal stresses in the metal where there's different tension and compression on opposite sides, so it wants to bend. I decided to experiment with a new blank. I heard that the way you solve the bending problem is to use shims. If you put something under the arc of the metal can't get pulled down. Then you can cut off a flat face. Then you can flip it and use that flat face to cut the high points off the other side. I tried to cut some paper that was about 4 thou thick to fit under the curve of the blank. This time, I put the blank at more of an angle. By putting it at an angle, the grinding wheel spends less time in contact during each pass. It makes the process slower, but this should make it heat up less. And I tried to only go down 1 thou at a time this time. I also increased the speed the table moves. By going faster, the wheel spends less time in the same area of the part, meaning it heats up less. The results were confusing. I tried to get rid of the arc, but I flipped it. Now I can put a shim under the other side. So I did. I figured maybe I relieved some tension in the metal by removing the scale. And it happened again. Now I could fit an 8 thou shim under the side I just ground. I thought it was just the scale still. But I did it again. No scale, and somehow still was able to fit a shim under the side I just tried to grind flat. So I finally tried something a little different. I shimmed the ends instead of the middle. I have to take off a bunch of material. But it actually seemed to go better. I took a bit of the hump off the other side and called it done. It ended up very close to my goal of 0.094, but it still had some bend in it. And it was a lot of work. I tried again on some other pieces, with only slightly better results. I was extremely confused at this point. I decided to do a test. I surface ground a large piece of steel. You can also see me trying to use a laser thermometer to see how much the temperature is changing. The metal always felt cool to the touch to me, but I thought maybe it's getting hotter where it's cutting. The room was around 83 degrees, and sometimes the thermometer would get to 90 or something, but nothing crazy. I later got the same readings on thin material too. I don't think it's a very accurate measurement though. I'm sure it's actually hotter in the cut. This is the 10,000ths of an inch indicator again. Now I felt more confident that the problem was with me and the thin material and not the machine. I had a lot of trouble figuring out how to measure things, especially in a way that could be filmed. I wanted to find a quick way you can see if things are bent. Here I have a piece of metal under an indicator, but this one just has half thou ticks. If I press on it, the needle will move because the metal has some bend in it. I found a piece of S30V that's very flat, so I can't bend it with my finger. It came pre-ground, so it doesn't have any scale. It's a few thou oversized. I thought it would be easier to figure out what's happening if I start with something already flat. So I ground one face of it, and this resulted in the other side being high by 10 thou. I used different colored markers to try to keep track of each side. I did the other side and the same thing happened. But this time only a couple thou. I'm still confused. The weirdest thing is, I would have thought that if the part is heating up too much, the material would expand and extra material would get cut away, and then it would cool, and you'd end up with a cove in the middle, and it'd be thicker on the ends. But that isn't what's happening. It stays a consistent parallel thickness, just with a bend. I kept trying, and on different flips it got better or worse. Eventually, it was within tenths of the right thickness, and it had about a thou of bend. I decided to do a test where I really try to minimize heat. I kept getting faster with my wheel dressing, and this time instead of 2 thou, I took a 10 thou cut. I heard you really want to open up the wheel so it stays cool or clogs less or something. I put the blank on the machine completely vertical, so the wheel is engaged for the shortest amount of time possible. I actually did this orientation once with the shims, and I couldn't really tell if it was an improvement or not. I also tried reducing the step over. I probably should have done this a long time ago. Unfortunately, the machine doesn't label its knobs. Here is about a 50 thou step over. I tried halving it to around a 25 thou step over. The step down is still 1 thou, which is basically what every cut has been in this video. I cleaned up both sides and it seemed to come out very flat. For some reason, this convinced me that the side of the wheel generates less heat. So I ran it again, but this time I went to my deepest ever 3 thou down, but with the same small step over. And I did add some bend to the blade, but the amount of bend was still much smaller than many other previous tests, which I would have thought were more conservative. So I felt like heat played a role, but I thought it could still also be different amounts of stress in different blanks. So I got another idea. Unlike the surface grinder, Grinding the blank this way does make the part way too hot to touch. All that heat should mean it comes out more warped, right? Not really. I don't understand anything. Maybe that's not a fair test. They didn't seem to warp much, but the parallelism of each side was pretty bad now. Another thing I wanted to try was bending. I put the same blank in a vise with some pins, and I was able to minimize some of the warp by bending it in the vise. Then I took this mess of a blank to the surface grinder. Again, around 25 thou step over, 1 thou step down, a couple times on both sides. And it was able to maintain the lack of warp. I probably could just use what I've learned and lay out a bunch of blanks sideways on the machine, but there was still one variable I was interested in. Here's some AEBL I tried in the last couple of videos. It's got some bend, and I had to mill the edges so it'll fit in my fixture. And I try to place it as flat as I can. The surface grinder isn't fast. It takes at least 5 minutes to take 1 thou off of one side. I'm wondering if it's worth taking a little off in the mill first. Then I also don't have the magnet issue, so maybe I'll have a better starting point. Okay, so it still has some bend in it. I tried to leave 4 thou, but again, it kinda is all over the place. Grinding didn't really go great. I'd have to go undersized to completely clean it up. I tried again, but this time I bent the part flatter before putting it in the fixture. And I even bent it again in between sides. This seemed much better, but I still might need a better fixture for the mill or something. I've still got a lot to learn about grinding, and I'm still not sure if I completely understand what's going on. Maybe stress relieving the steel in the oven before grinding would be a good test. I'd like to avoid making a mess if I can, but I could try spraying some coolant or using Crisco again. Hopefully I'll learn something from the comment section of this video. The machine from the start really accomplished what I wanted though. Even though I'm struggling with bend, the parts are very parallel and basically right on the money in terms of thickness. I'm not even sure how much I should be worrying about bend. How much of this bend is going to come back when I do a bunch of machining on the blades, and then I try to harden them, and then more hard milling. That's all putting a bunch of stress in the metal that could screw up my perfectly flat blanks. Then I might just want to bend them anyway because that's how scissors are. And another reason it might not matter is I didn't really get this machine for production actually. When I can do higher volume, I'll have the blanks double disc ground. I think that's a better process for just quickly getting the blanks flat prior to machining. I got this machine to learn and experiment, and because even if I don't want to do all the grinding myself, I want to have a backup plan that doesn't rely too much on other businesses. I hope you found this interesting. Next video, I'll probably get back to more normal machining. Thanks for watching. See ya.